So guys, wait for 5 minutes and then we will start class at 6:05. Uh, let other people join, okay?
I तो कौन ही राजू
Hello. Yes.
तुम बंद कर
Uh, Harsh, you were
Mana
saying
kabut ni
something?
time to connect. Pinapil.
Uh, okay. Harsh, if you don't have anything, then please mute yourself.
Eh? Magkabit.
Okay, people are joining. Meanwhile, yeah. Let's wait for a few minutes and then we will start, okay? Okay, maybe we can begin. So, welcome everyone. So, this is an interaction session or doubt solving session for this NPTEL course, which is Matlab based programming in chemical engineering lab. Okay, I'm Bhavesh Moorjani. So, I will be TA for this doubt solving session or interaction session, right? Let's begin with the brief introduction about me and then I will discuss about outline of this interaction session, what are we going to do during this interaction session and how we will proceed. So every week I will be taking this live interaction session from 6 to 8 p.m. There is another TA, I think her name is Sandra. So she is taking class probably on Friday around same time 6 to 8 p.m. right. So we will be both of us we will be following our different approach towards this live interaction session. She has her way of teaching and I will do according to my planning, right? So our live interaction session are different. You can join either of us, both of us, or even this video recording of this live interaction session will be available at in the YouTube channel, so then you can check that also, right? Just brief about me. I'm Bhavesh Moorjani. Currently, I'm doing Ph.D. at IIT Bombay in the Chemical Engineering Department. I have completed my graduation from MS University Vadodara, where I was first introduced to this Matlab course, Matlab programming, and after that, in my PhD work also, I use MATLAB programming here and there. Right. Just for your information, these are the some of my socials. If you want to contact me regarding this MATLAB course or you have some other doubts, you can contact me there. Right? Now, before starting to the course, let me tell you about this interaction session and where you can find them. So in your Swayam portal, where you can access the course, right now they have not created a link, but at the bottom of this week 1 week 2 lecture content, you will have this Q&A session and doubt solving session tab, where you will be provided a Excel sheet link, which is like this, where every week's recording will be there, and the presentation that we will be following will also be uploaded here, right? So as of now the NPTEL team has not updated it, but if I show you in some other lectures, sorry, it should go to my course. Yeah. Not this one. So this is the previous course for which I was a TA, that was on Aspen Plus, right? So yeah, here you will have this problem solving session tab, where you will be provided with this Google Sheet link, where all the lecture recordings and the corresponding lecture notes will be available, right? So this I'm informing because somebody in the Q&A forum asked about the how to access the lecture recordings, right? So as of now they have not updated it, but I think they will update in this week or by the start of next week. Okay. Another thing, you can join this Q&A portal to discuss doubts among yourself. I'm also joined into this Q&A portal here. You can access this from the course tab, right? So if you have doubt, I think people are already discussing it, and somebody had asked how to access the interaction session recording. Okay, so maybe you you can discuss among yourselves to figure out assignment, or if you have any small other doubts, right? Else, obviously this interaction sessions are there. You can contact me or other TA to discuss it, right? This is my YouTube channel where this videos will be uploaded. You will be provided the link also. Okay. So coming to the content of this live interaction session, so the method that I will be following is at the start of the session, we will be recalling what sir has taught in the previous week session, slightly brief overview of what he has taught, and then after that we will move forward with the problem solving part, where I will be discussing various problem in the Matlabs. We will solve different questions, right? Regarding the assignment, I cannot directly discuss the current assignment with you. Once they are completed, then you can discuss if you have any other doubt. But for a current week assignment which are live, I cannot directly discuss it with you. Okay. We will be solving similar sort of a problem so that it will help you to solve the assignment problems. Right? Now the content of the course, if you have seen it for week 1 and week 2, it's basically the introduction of modeling and programming part, and the week 2 content is live, where you will be seeing that sir is teaching the basics of the Matlab, right? So for my interaction session, like this 2 week, I will be discussing basics of the Matlab programming, various fundamental commands, prompts used in the Matlab, various basic loops, and then after that from week 3 onwards we will be solving chemical engineering problems, coding them into the Matlab, right? Just a minute. Okay. And one more thing, if there is any internet connectivity issue and if I get logged out, just wait for me. I will join this link again in few time. Okay. So let's begin with the today's class. So as a chemical engineer, when we talk about any chemical process, right? So chemical process starts with the raw material as an input, and then this raw material are subjected to various physical operations, unit operations, be it heating, compression, or size reduction. Maybe you might have site segregation, and then after that they are subjected to your unit processes, which are mostly involve which mostly involves chemical reactions, right? And then after that, once the reaction is completed, product separation part occurs, where you have distillation, adsorption, liquid extraction, various processes, and then at the end you get the final output, right? So this is the whole process of getting raw materials converted into the product. So as a chemical engineer, our job is to design, operate and control various unit processes and operations involved during this whole process, right? Now the more complex the process become, the more involved our job becomes. I will come to that by I will come to this sentence, what I mean by that, right? So in order to understand how to model this entire raw material to output product path or process, we have to understand the modeling and simulation part. So if we talk about modeling, so modeling means kind of representation of a complex system. Model could be a simple equation or set of equations that represents our behavior of system, right? Which generally usually is in terms of mathematical equations, which help us to predict the behavior of our system, right? Which is useful to understand how real world problems will be solved. So let's consider basic example, heating of an ice block. So suppose we have an ice block present in our system. You can consider ice block is present in your room, which is kept at a floor or someplace, right? So there are three modes of heat transfer that we know, right? Conduction, convection and radiation. So if we want to model the heat transfer from the ice to its surrounding, and so we can model this heat transfer with the basic three mode of heat transfer. You have conduction, which will occur from surface contact. Then you have convection. In convection also you can have natural convection, forced convection, and then there will be radiation, right? So for all of this heat transfer, we have a set of equation already there. So these are the basic fundamental equations that you must have learned in the heat transfer. So these are nothing but, this itself is a part which is called as modeling, which is useful to understand the how temperature of this block will change with time, right? So when we say modeling doesn't have to be a very complex thing. It doesn't have to be a very set of like complex set of equations, differential equation, partial equation. A simple equation of heat transfer, that is also a model, right? And when we mean simulation, so when we use this model to predict this system behavior, that becomes a simulation. So again, the modeling and simulations are not very complex terms. So they start from the basic and can go to the complex part. So if we do hand calculations and find the temperature profile of this ice block with time, then that is also a simulation. So you are using that model to simulate the system behavior, right? So simulation is use of model to study how actual system will evolve. It involves, you might also run some experiment and then compare your model with the experimental data, right? So they are interconnected. We observe physical system, we try to form a model, and from that model we run various hypothetical scenarios. So we basically simulate, calculate result and explain the physical observation or macroscopic observation that we have, right? Now combine modeling and simulation for us as a chemical engineer is useful to predict various system outcome, optimize the performance of system, right? So let's consider the basic example of process plant simulation. So here I have this Formox process, which is used to produce formaldehyde from the oxidation of methanol, right? So you have one liquid methanol coming to the evaporator, where it is mixed with the preheated air. It goes to your reactor where the conversion of methanol to formaldehyde occurs. Then reactants products are cooled down, and then the adsorption of this product gases happens, and at the end you get the formalin solution, right? So this is the basic process flow diagram of formaldehyde production. Now here from this flow diagram you can see the equipments that are involved. So we have pump, we have compressors, we have these two heat exchangers, one reactor, evaporator and scrubber, right? So now let's think about it. If I want to simulate this process or find out or do its mass balance or energy balance, right? So what things I will need, what calculation I have to do. So can you guys think about, so let's say I have this 6 major equipments, right? Reactor, scrubber, heat exchanger, pump, compressors and evaporators. So which of this will require mass transfer, which of this will require heat transfer, like sorry, mass balance and heat balance calculation. So for reactor we will have both mass and heat transfer, right? You guys can answer, right? If don't worry, uh, don't feel shy. This is an interaction session, so I will expect some answers from you guys. So for reactor, do we need both mass and heat balance? Yes or no? Yes, right. So for similarly for scrubber also, scrubber there will happen an adsorption where the product gas will be absorbed in the water. So there is obviously mass balance. Will there be a heat balance for the scrubber? Scrubber or absorber, what you prefer? See here, the water is coming at 20 degrees centigrade and our product is at 125 degrees centigrade. So if I have to do energy balance, obviously there will be energy balance since the both liquid water and the gas inlet are at 2 different temperatures. So there will be heat balance. For heat exchangers, obviously we will need heat balance, but do we need to do mass balance? Yes, no? No, right? So heat exchanger mass in will be mass out, so we don't have to do mass balance there. And for pump we don't require mass balance. It will just put out the input stream at a higher pressure, so no mass balance. Do we need a heat balance here for a pump? Can you think about it? So actually no. If you have a very high heated system, then in some cases you might need it, in some cases you might not need it. Okay, so generally losses in the pump are very less, so you don't have to worry about. For compressor, we don't need mass balance, but since compressor will compress the gases at much higher pressure, there will be energy generation, so heat balance is needed. And then for evaporator we have heat balance, right? So this is the checklist. So when I want to simulate this process, if I want to compute that, let's say if I have x and y amount of methanol, y amount of air coming, what will be my product, what will be my formalin solution at the end that I will get. So if I think about it, in this mass balance and heat balance calculation, what kind of equations I have? I have linear equations for mass balance. I have ordinary differential equation that might come into my reactor part, right, where I have to find the conversion, which are generally partial differential equations. Okay, there might be some coupled equations during the heat balance part. So if you think about it, then in that sense it seems like a simple calculation that you can do it by hand, right? But the complexity comes when there are multiple reactions happening inside the reactor. Okay, or you have to optimize the reactor conditions, or find the temperature profiles, design the equipment. So if you must have studied about the designing of distillation, if you are in the final year, or if you are in the first or second year, you will be studying the mass balance and energy balance in the distillation column, where there is this mass and energy balance at every tray that we do, right? So let's say if my absorber column here, it contains of 20 trays, so then at all 20 trays we have to do this mass and heat balance. If we want to design it, then further we have to, there are various methods already available that we have to implement. If we want to compute, if we don't have a property of our system, right? So then to compute the thermophysical property, you might have to use various group contribution method to find the properties in such calculations, right? So as in all this, there is too much complexity involved when we talk about the designing or development of any process as a chemical engineer, right? Now not all of this calculation can be done by hand, obviously, right? So we have to use or rely on some sort of a software, we have to rely on some sort of a numerical method, right? Not everything is solved analytically. Let's say for the reaction engineering part. So for simple reactions which follow the first order or second order behavior with only one component dependent, you can solve it analytically, right? You will have your reaction engineering equations available with you. But if the reaction is multi-component, in that cases solving it analytically is not possible. Then you might have to rely on some numerical methods. So that's where the need of numerical methods and the simulators comes in, right? So solution to solving this complex process is that we have to rely on numerical methods and various software and packages, right? So in that software there are two ways we can go for or look for. One is commercial software, and then second is you develop your own algorithm and code, which sir refers as an ab initio programming, that you might have seen in his presentation, right? So if I talk about commercial simulators, you have Aspen Plus, HYSYS, DWSim, which are used for process plant simulation. HTRI is for heat exchanger design, right? Then you have COMSOL, which is for fluid property behavior prediction, right? So basically people who work in fluid phase use COMSOL. You have AutoCAD. Have any of you used this any of this package or simulators? Yes or no? Are you familiar with
I
any
am.
software? Yeah, yeah. So
I have used AutoCAD.
you have used AutoCAD, right? So for what purpose you have used AutoCAD?
For the 3D modulation,
Yeah. So
for
for yeah.
creating 3D objects.
Yeah, so for printing 3D objects. Similarly, there is AutoCAD for PNID designing part also, right? If anyone have used Aspen or DWSim, so in Aspen and DWSim you have this modules of heat exchanger reactors and various libraries to compute physical property already available, right? With the help of which you can simulate entire process. So the advantage of using such commercial simulator is that it includes most common processes and operations which we already have. But then slight limitations comes, is that we have to rely on inbuilt modules and packages. There are some degree of customization that you can do in this softwares. So for example, Aspen Plus, you can use some coding part to implement your own model or your own equations, but that customization might be limited, right? So the advantage of using your own code is that you get more customization over your own system. So let's say you want to simulate so that is this let's consider cooling of a liquid through a pipe, right? A simple shell and tube heat exchanger. So hot fluid is on the tube side and the cold fluid is on the cell side. Now you want to see how exact this transition, how the temperature change occurs from inlet to outlet. Then this packages might not be useful to see that profiles, right? So in that cases, let's say you have used your fundamentals and developed your own code to visualize the change in the temperature with the length of tube. Okay, then you can see how exact these changes are occurring. So you have more customization when you do use your own code, but kind of slightly disadvantage is that you have to write your own code, which is slightly involved, but is doable, right? So in this course, what we are focusing is this ab initio programming, where we will be using our own codes to solve the chemical engineering problems, right? So this again is taken from the source PPT, that ab initio programming, which is again part of modeling and simulation. So first step is to model your system, right? So let's say you want to understand how concentration is changing in your batch reactor or CSTR reactor. So first you have to model your system. So for that you have to look for the physical characteristic of your system, form out the mathematical expression for that system which best represents your system, right? So all of your engineering fundamentals that you have learned, the reaction engineering part or heat transfer, mass transfer part. So what we study, these equations are nothing but the model which represent our system. So that step one for us is clear. Okay. Now the next category to simulate the our process is to identify mathematical categories. I will come to that. So the kind of equations we have to use to model our system, under which category they fall, because the solution to that equations again will follow what kind of category of equations we have, right? So then step 3 is to identify numerical methods for the solution of this equation, and the step 4 is implementing this technique in our program to understand the changes. Okay. Now for this step 4, where we implement this numerical methods to solve these equations. For if you are writing your own code, then there are various languages available. So you can start with the fundamental language such as C, C++, Fortran. Then there are more object-oriented programming, Java, Python, Matlab, or R programming, right? Now, sir has already explained the difference between the compiled versus interpreted language, so I'm not going into the details of that. But what I would like to focus is on the understanding of difference between what you get when you what you have when you use basic fundamental language such as C++ and Fortran versus Python and Matlab. So have any of you used any language from this, or do you know the difference, like what advantage you get when you use Python over C++? Do you know, or have any of you used any language here? I guess no. So let's say I use C++, I have also used Python, I have used Matlab also, right? So C++, since it's a fundamental language, it's robust, it's fast, but then it doesn't have too much packages or module available. So even for basic operations that you have to do, basic mathematical equation, let's say you want to find the determinant of matrix, then you don't have a command for that. You have to write your own small functions to compute the determinant of a matrix, and in C++. If you want to find the maxima minima, so you have to write small functions. While Matlab or Python, they have much more inbuilt numerical packages for this computation. So all the recent languages, specifically the Python, which is currently so much in use, is popular because of the so much of variety of libraries available for the computation part. I will come to that also when we will start the Matlab. When we will discuss the Matlab commands. I will put a light on what difference you have when you use the basic language and the Matlab language. But the advantage of this new object-oriented language is the support of various packages which you don't have over previous language. Right now. As I said that in step 2 and 3 is identifying the categories of various equations and numerical solution for this equations, right? So as a chemical engineer, the common equations that we encounter, it could be linear algebraic equations. So when you do mass balance of multi-component system, right? So at the end you can write it into the matrix form. So it's a system of equations you get. So these are all linear equations. Non-linear equation generally comes specifically in the reaction equilibrium part, where you compute the rates, right? So they are mostly non-linear power dependent equations. You have ordinary differential equation with initial value problem. So let's consider batch reactor example, where you know the initial concentration, and then so initial value is known and you want to compute the composition over time. Then you have ordinary differential equation with boundary value problems. So if you will recall in your reaction engineering, the reaction in heterogeneous catalysis, so you have this shrinking core model and progressive core model, right? So there you have various boundary conditions fixed, and based on that you model your system. So these are ordinary differential equation with boundary value problems. You might have coupled ordinary differential equations. So let's say non-isothermal PFR, where you have both concentration and temperature changing So now since concentration is also dependent on the temperature from the rate constant, right? So you have both coupled equations. There are spatial temporal equation, so which includes change in both space and time. So uh, the above discussed various equations you can differentiate into the spatio-temporal or the combined part. Or you might have to do optimization to find the optimum reaction conditions, find the pump efficiency, or pinch analysis. So pinch analysis is finding the optimum heat exchanger network. If you want to do plant economics, you have to set the pricing for the optimum profit or minimum production cost. So that is an optimization part, right? So as a chemical engineer, we encounter these problems on a regular basis, right? We might not label them specifically, but when we are computing and evaluating, when we are modeling it, we have to consider what kind of model we are using, because solution of all of this requires specific numerical methods, right? Now we understand, okay, so what we learned till now was that for ab initio programming we need model which represents our system, and then we need a numerical method to solve our problem. Okay, now for that we will rely on our own code, we will develop our own code. So for that, here I want to touch one aspect, which is understanding logic over syntax. So what do I mean by that? So right now you are learning this course to understand the Matlab and use of Matlab for chemical engineering application, right? So here we will be generating our own codes, but my suggestions to you guys will be to focus on the logic building part of your model rather than the syntax of any programming language. Because if you know the basics of fundamental logic, then you can use same logic to various languages. So let's consider if I want to write a code which differentiates odd and even number in my given vector, right? So how do I differentiate odd and even number? Can anyone answer if number is odd or even? It's very basic, please answer. How do I differentiate if number is odd or even? I divide it by it's very easy. So yeah, go ahead. So let's say I divide it by 2 and see the remainder, right? So if I differentiate number by 2 and if remainder is 0, that means number is even. If we have a remainder, then it's an odd number, right? So this is the basic logic, right? So let's look at across various language how this code will look like. So for C+, you have to define an array. So I have this array from which I want to differentiate whether elements are odd number or even number. Okay, don't worry about the this for loops or exact logic, but basic fundamental is I have to divide the number by 2, and if the remainder is 0, then number is even, right? So same thing is followed here, but in C+, you can see this code is slightly lengthy. When we come to the Python, so Python same for loop is applied, where I go to the each element of a number and then check the remainder. When I divide it by 2, check the remainder if it's 0 or not. Okay, so same I do it in Python, but the for loop is slightly compact here, where I check if the division of the number by 2 gives a 0 remainder. If yes, then number is even, or else its number is odd. Now same thing when I code in Matlab, again same ideology, like same logic is used. Now the syntax is different, right? So in all you can see I'm screening through the each element of vector. I'm applying the if condition on that element and checking if number is even or odd, right? So same logic, but syntax are different. So if I know the logic here, right, if I know how to find whether number is even or odd, then I can code it across different language. Just what changes is the syntax of the language. Now with the use of AI tool, right, obviously you all must have by now used any AI tool, ChatGPT, DeepSeek or Grok, any other GPT tool, right? So there you just write a prompt, it will create you the script. It might give you the basic idea of how to create a for loop in Matlab, how to create a for loop in Python. Okay, so that is easy, but the logic part is important, so that if you have that idea, then you can build it upon it with the help of this tools, various tools which are available, and then your skill will be not limited to any specific language, right? So throughout the course my suggestion will be to focus on the understanding part rather than just implementing in the Matlab. Obviously knowing the syntax is useful for a faster coding. If I know how to which command to use, how exactly do looping in Matlab or let's say in Python, then my coding speed will be faster. I can work faster. Let's say I might finish it job in 2 hours rather than 4 hours if I have to search for the command, right? So that is obviously, and knowing syntax is an advantages, but focus on the core part, which is understanding the logic, right? There are various coding language available, out of which we are focusing on the Matlab. Why Matlab? So Matlab is specifically designed for this matrix calculation. So its name stands for the matrix laboratory, right? It's widely used for various applications. This is the basic introduction if you will search on the Matlab website, right? There are various packages already available which you can directly utilize to compute properties which makes your work much easier. Now compared to that, if I have to work with the fundamental language, let's say C plus or Fortran, then I might not have a support for this vast packages. In that case I have to work much harder to build these packages on my own. Rather than that, if I use Matlab or Python, I have this inbuilt packages available. So with the help of Matlab, there are these various tasks which are easy to do. So numerical computation, where matrix operation, linear algebra, you can solve it. You have methods to solve ordinary differential equations, where there are various mathematical functions already available, statistical analysis tool, etc. Plotting and graphics visualization is much more nicer in the Matlab. You can write your own code and script to compute specific tasks. As I said, people use it for various applications, so there are packages available to do controlling, even machine learning, deep learning, image processing part, toolbox are also there, which are add-on to the built-in Matlab packages, right? And even it's interpretable, you can use some of the C plus or Python libraries to integrate it into the Matlab, right? So this is why the advantage of using Matlab here is that since you have support for this vast library, it makes our job much easier. Okay, so having knowledge of why we need modeling part, why we need to do coding, and the various available option of programming, out of which we have selected Matlab. So we will start with the basic introduction of Matlab. So as I said earlier that first 2 week I will be touching the basic aspect of Matlab. So before that I want you guys to fill this short survey. So either you can scan this QR code, I will paste it here also. So we can wait for 5 minutes. I just want you guys to fill this form. So it's a basic Q&A about how much familiar you are with the Matlab or any other programming language, or the basics of programs such as for loops, if loop, etc. Right? So I will use this information to kind of optimize how to approach this course further down the line. So for those students who will be watching this lecture on the YouTube, you can use the scanner, or if this PPT is available by that time, you can use that link. Okay. So I will wait for 5 minutes, and please fill this form. So this is how this form looks. So it's just if you have used any programming language, how much familiar are with various loops and conditions used in program, how much familiar are you with MATLAB and stuff, right? Because in today's class what I will do, I will touch the basics of MATLAB, and the next class I'm planning is on using various loops, if loop, for loop, sorry, if conditions, for loop, while loop, basic, how to create your own functions, plotting part. So if this will help me to decide how to proceed with next week content. I will wait for a few minutes, you can do it. Okay, hers has filled it. Everyone has filled it? Shubham also, yeah. Just 1 or 2 minutes and then I will resume the class. For the online audience, I would also recommend you to fill this form. Not online audience, basically people who will watch in YouTube. Do fill this form. Okay, so let's resume. Now, so there are various free courses offered even by MATLAB itself. So if you will see the MATLAB page, you know, they have this various courses that you can enroll. I think most of them are free, right? So according to your need, you can enroll in the course. They are basically for few hours, 1 or 2 hour courses, where you get the knowledge of basic MATLAB programming part, right? Out of which I suggest this course. One is obviously MATLAB on ramp, which is there in your Swayam portal suggestion also. Then how and why to writing function, programming in MATLAB, how to use graphics in the MATLAB. So this will help you to understand various plotting part. There are core MATLAB skill course and this optimization on that. So this will give you basics of MATLAB and help you to gain confidence in the MATLAB program. There is this another course, NPTEL course, which is by Professor Niket. Right now I think this semester this course is not running, but you will find its playlist on YouTube itself, so you can check that out also. For the book part, I personally have used this book by Professor Rudra Pratap, which is getting started with MATLAB. So you can use that, or either if you have already know other MATLAB programming books, you can use that. I personally found this book very helpful, since it's a introductory book, so anyone who is starting with MATLAB can utilize this, right? So now let's get started with MATLAB. All of you have got the access of for MATLAB, right? I assume, because I had checked it on the Swayam portal, so you get the online access of MATLAB, right? MATLAB Online. I am using my IIT Bombay's license, so I have this MATLAB app. But both things should work. Even MATLAB Online has a good capabilities. For those of you who don't know, MATLAB also has a mobile application, so you can check MATLAB mobile app also. It's not very convenient, but if you want to learn, you can use that part, right? So once you open the MATLAB portal, MATLAB window, this is how it will look like, right? So on the top you have your toolbar. First, the main window, which is command window, where you can type your various command, right? So this is the command window. You have this workspace where you can see your variables. There is this command history prompt also, which I have opened. You have your folders path where you can see various files which are already there, details of any file. If I click here, I can see the basic of file. Then the editor window you have. So by default, if you will see, this is the default layout, which I personally don't prefer. So I do tend to shift editor on the side. Just a minute. You can customize it here accordingly. All but command windows. And I have lost it. This should also work. Anyway, right. So in the command window, you can type various commands, and the output of which will be shown here. As well as in the workspace, you can find your variables. So let's begin with this. Just a minute, I have to change this layout. Should work. Okay, doc. Yeah. From here, I cannot do this. So you customize it accordingly. I like it this way. So this is the editor window. Now when you click on new script, it opens into the editor window. So default extension for MATLAB is .m file, right? You can see there is this live script also. So difference between new script, which is .m extension, and .mlx extension is in this mlx extension, when you type the command, you can see the output side by side, and you can run it without saving the file also. So it's useful for the debugging part. So it's kind of a live script, while this .m file is your regular script, which for the output for which you see on the your command window. Okay, we will check both out. Then there are options. You can navigate through various files, create your own file. Here, if I want to access any other files, I can do that, right? Then you can import various datas. So if you have any CSV data, let's say you have done some experiment, and then you have your temperature concentration profile for any reaction, you can import that data, which you can later use on your code itself to find out whatever you are doing, right? there are various debugging tools also. So this plotting window here will help you to analyze your result graphically. Right now it doesn't show any prompt because we don't have any variable. Once we have various variables, we can access this tool. There are various apps. So these apps are nothing but inbuilt packages that you can install in your Matlab. So there is this optimization package. I have not used much of these packages, but since it supports various packages, there are machine learning packages, so you can add on these packages for your work. Okay. If you have any doubt, there is this search bar where you can search any keyword and it will show you the its result. So let's say I search for the plot and press the enter, so it will look for the Matlab documentation and then give me the result for that, right? So with plot there are various things associated and you can check it. We will come to this part also again, right? So this is the basic layout of your Matlab window. Now let's start with the very fundamental. So what I will do, I will go through various basics command in the Matlab. It won't be very intensive. If you have already done Matlab on-ramp course or any other course, then it will be kind of basics to you. But if you haven't started working with Matlab, maybe this will help you, right? So first thing first, the percentage symbol, it's used for commenting. So if I write this so this is a comment. So if I want to write comment in my script, I start with the percentage symbol, right? Now if I want to declare any variable, so for Matlab it's very simple to declare a variable. So let's say I want to assign a value of 2. So value of 2 is assigned, and you can see in my workspace I can see a is equal to 2. If you will double click on this, it will open your matrix window and you can see a has a 1 value, 2, right? Now the upper arrow key, with the help of upper arrow key you can access the previous command also. So here if I don't use the semicolon at the end of line, then the output of the whatever prompt I have used will be printed in my command window, right? So I have written a is equal to 2, it's showing me output a is equal to 2. If I don't want to see that, I can just use semicolon. Now when we define the variables in the Matlab, so for variables there are certain rules that we have to follow. So variable name should start with the letter itself. It cannot start with the number or any special character, right? We can use number in the variable name, but it should not start at it should not come at the start. It should start with the letter only, and only special character that we can use is underscore, right? And this variable names are case sensitive. So if I write a is equal to 2, okay, so this creates a double a variable which has a value of 2. If I write small double a is equal to 3, which creates a different variable, right? So you can see all these 3 variables are different since it's a case sensitive, right? If I start my variable name with number, let's say I write 1b is equal to 4, it will give me an error. It says invalid expression because variable name cannot start with number, right? And even it is suggesting that do you mean do you want to start with the variable name as a letter, right? You can use underscore to differentiate various variables. So let's say I have some temperature data with various time steps, right? So let's say t is equal to 1 time step, I have temperature value of 270 Kelvin. I can write it as t equal to 1, t underscore 1. Second time step I have some value, so I can use underscore. So variable is same since it's a temperature variable, but I have multiple temperature data, so I want to differentiate them, so I can use underscore to assign numbering after that, after starting of my variable, to differentiate multiple values, right? So same thing, you can add so many variables as much as you want. Now there is no specific limit on the characters part. You can use much longer name also. Generally, it's good practice to use a variable name which is more logical and is easy to understand, right? So as of now I'm using ABC, but when you are coding or you are writing your own program, it's a good practice to use a variable name which is easy to recognize and recall. Okay, now if I want to manage how much of what variable I have in my system, right? So for that you have this woo command. So if you write woo, it will show you whatever variable you have present in your workspace, right? If you want to understand, if you want to find specific command, so let's say woos, and I want to look at the specific command, specific variable double A. So if I type woos double A, then it will show the variable, its size, its memory, how much memory it takes. So it takes 8 byte, right? If I want to delete any variable, so I can use the clear command. Now mind you, here if I use clear, it will delete all the variables. If I just want to specifically delete one variable, which is the small aa, so I can use clear aa, and you can see it has gone from the workspace. I can check again. So here small a variable has been removed from my variable list, right? If I want to clear all the variable, you can use clear all or just clear command, so it will remove all the variables. If you want to clear your command window and keep it neat and clean, let's say I am trying this but I don't want to look at the previous part, you can use CLC, which clears the window, so all the previous part has been is gone, right? Now there are other commands also. So you can see the variables with who and whos. To keep your environment clean, you can use clear and CLC command. Now we already saw how to use how to define the variables and its naming scheme. Now let's look at the different operators that we have for the Matlab programming. So by operator I mean the mathematical operator. So for here, so various numerical operators by default which you have in Matlab are plus, minus, multiplication sign, then division, which is right division, left division, and the exponent power. Okay, so let's look at all of them. So if I want to multiply two numbers, right, so you just use 2 multiplication 3, it will give you the answer. If you want to find the power 2 to the power 3, it will give you the cube root of cube of 2. Okay, if you want to use 2 so then you have subtraction. Now in the division part, you have 2 symbols here, left division and right division. So how does they differentiate? So if I do 3 by 2, so this is a right division, it will divide 3 by 2. But if I do left division, this will divide 2 by 3, so I get 0.66 value. Okay, so the need of this might come into your code. Obviously 2 by 3 left division 2 is equivalent to 2 right division 3. Okay, but in your code you might come to some places where you have to use this part. Okay, just for ease of it, so you have that symbol also. Now by the way, this font is visible to you guys, right? It's easy to read, or should I zoom in more here? Can any one of you say this font are visible, or
Zoom in later bit.
okay, let me just check. Page setup. No, it's not working. It should work. No, it's not changing. Let me restart it and see.
तू सुन रहा है नहीं?
Please mute yourself. I'm not sure, it's not working as of now. So I know we can control font size here. This I can increase, but for the command window I don't know. I will check it out and try to resolve it in the next class, right? So maybe I can run the command in another window. Okay. Right. Now in this operator that we have used, so the order of operation, it follows like this. So first priority is given into the bracket, then you have the exponent part, then multiplication, division, they basically have same priority, and then addition and subtraction. Okay, so by this what I mean, so let's run this part, that see I have used .m file. So before running I have to save this file. Okay, and then after that I can run it and it will show me the answer here. Okay, now if I use the live script file, same thing, and you can run it and see your answer side by side. Okay, so this is the just difference between .m file and .mlx file, that this is a live script, so you can see results simultaneously without saving it. So it's useful in when you are debugging your code. Okay, now here I don't have provide any parenthesis for my operation, right? So first priority is given to the multiplication and division, so it's doing 5 by 3, then multiplying it with 2, 4 into 3, and then adding it with the second part, right? But if I do so I'm providing the parenthesis where I'm saying that first do this multiplication and then divide by 3, then my answer will be different, right? So this is important when you are using bigger equations, so you have to be mindful about where your division comes, where your multiplication comes, and it's always better practice to use parenthesis, which is this bracket, to define or to differentiate your numerical operations. Okay, now let's say you don't know any command, or you are unsure of what exactly this command does. So in that case, in your command window you can write help followed by any command name. So let's say I don't know what this left division operator does, so I do help, and this this is right division. Okay, so what it does is gives b division b by a value, right? So this is the help part. So if I want to do help sum, I don't know what sum command does, so I can write help sum, and this will give me what exactly I can do with the sum command. So if I write sum x, it will give the sum of elements of vector x. Okay. If there are further customization, then you can do that also. If you want to write, if you have a matrix and you want to do summation of that, you can do this also. Okay, so all of this is given here. Now if let's say you are still not satisfied with this help command, then what you can do, you can click on the documentation for sum, and it will open the document part where you will have various examples for same command, right? So here you can see first you are doing summation of a vector, then if you want to do a summation of matrix, so how it will do the summation. If you want to do the summation of row of a matrix, then how you can do it, right? So the detailed description of any command along with the example is given in the documentation part. Okay. When you write help, that help and followed by command name, you will get the basic information. If you want to see the example, you can search in the documentation, or you can search here directly also sum. Okay, and I will get the document same details here. So this is useful specifically when you are starting with the language and you don't know which command to use or what exactly that command does, right? So let's say I want to do multiplication, but I don't know what that command is. So I have just typed multiplication and it's showing me which command to use to find the to multiply two components, right? So you can also search the relevant keywords if you are unsure of how to perform any task. If I want to understand how to do a plot in a Matlab, I can just search plot and it will provide me all the relevant search with plot. Okay, so in plotting also there are 2D plots, 3D plots, there are heat maps, histograms, etc. So all the associated things I can see here. You can see there are multiple pages, so many results with this, right? So there are contour plots, color plots, surface plots, etc. So this is very useful, particularly as a beginner, to understand various commands. So this is the help command. Now this first we understand how to define the variables in a Matlab, what are the basic numerical operations that we can do. Now as I said, in Matlab there are various functions and library already pre-built to find to compute various properties, right? So if you will type help el function, it will give you all the basic operations, basic numerical functions that you use for your calculations, right? So you can see I can find the sine, cosine value, inverse of sine, cosine, right? Tan, sec. If there is difference between sec and sec d, you can see here. So one provides me the for one we require a radian value, one we require a angle in a degree value. Then for the exponent you have log base 10, log with base 2. Okay. For a complex for complex numbers, you have you can provide the complex number, you find the absolute value, conjugate value of it, imaginary part, angle of the complex number, etc. Right? So this is the basic commands that are already used. So let's look at them one by one. So as I was saying here, so if I type sine 90 and run this, it gives me the value of 0.894. So here in my mind I am thinking sine 90 as a angle in a degree, but by default sine command takes value angle in a radian. If I want to be specific that my angle is in degree, then I have to use sine d, then it will give me the correct answer, right? And if I have to use here, let's say in a my units are in radian, then I have to use pi by 2. So here pi is a default variable name which is used in a Matlab to represent your pi value, right? So here if I type pi, so I get the value of pi. Now in Matlab you can sometimes override the default variable. So let's say if I want to assign a value of pi 4, then pi has changed its value, right? So now my pi value is 4 and it has become a variable. We saw that summation is a command, sum is a command, right? But if I want to assign sum as a variable name, then I can create that also. Now whenever I will use pi next, it will consider it as 4 and not the actual pi value. To remove it, you just do clear pi. Similarly, I created the sum variable. Now next time when I use sum command, it might confuse it with the sum variable. So in that case, it's better to avoid such default variable names. There are actually very few. One is pi, then you have nan, infinity, etc. Infinity, and there are 2 3s. I forgot as of now, but I will update you on that. Yeah. What I will do is I will also upload this script from which I am referring right now. So if you want to check later on, same thing will be available to you. Now let's say I want to find the inverse. So inverse of a cos. So one will give me the value in degree, one will provide me value in radian. Oh, sorry. Yeah. Right. So obviously for degree and this is same. Let me change to. So a cos d gives me the angle in degree, while just a cos gives me angle in the radian part. Okay. Now the other command which are frequently used, one is this square root. So if you want to find the square root of any number, you can use sqrt and you can find the square root. Then often when we do the calculations, you have to do rounding of the numbers. You might have to correct it to the nearest integer values, right? So for that you have various options. One is round. So if you do round 2.3, what it will do, it will correct it to nearest integer. If I do round of value 2.8, okay, so it will give me the value of 3. So nearest integer becomes 3. But let's say I don't want to look for the nearest integer. Rather, I want to look at the integer which is like lowest nearest integer, right? So in that case, you can use command floor. So what floor does? So here you can see the prompt also, that round towards the negative infinity. So if I have floor and I use t.2.3, floor 2.8, same thing. If you will run, so for the floor it will round it off to negative infinity. So we have the value of 2, right? If I do floor minus 2.3, in that case I will get the value of minus 3. Mind it, because it's trying to look for the negative infinity. If I want to round it off towards the positive infinity, nearest integer towards positive infinity, then we have ceil command, which rounds off the value towards the positive part, right? Towards the positive infinity. So in this case I will get the answer as a minus 2. There is this another command which is fix command. So what does fix command does is, fix will try to round it off towards the 0 value. So if I do fix minus 2.3 and fix 2.3. So this is how it will provide. So it's trying to go towards the zero value part, right? So in that case you can use fix command. You might not you might not be able to understand the use of this command as of now, but as you move forward and do various analysis, then you will understand sometimes we have to use such analysis, like such rounding of part in our codes, right? If I want to find the factorial or remainder of anything, remainder value after division, so then I can use rem 10 by 9. Okay, so you have to provide two values, so it will divide 9 by 10 and give me the remainder value. Okay, same thing you can check. I provide 9 by 10, so here my remainder will be 9. So it's then we have factorial and exponent part also. So factorial, what does it do is finds the factorial of number n, right? Now here see, input information is also given that your input should be scalar, it could be vector, array of real or non-negative integer value. So if I do factorial, it gives me this answer. I can put any value. Let's say I want to find the factorial of 27 and you will get that. Now coming to the next part, so there are various relation operators that are being used to set a logic in between, right? So the relational operators that you have are this, which is greater than, less than, greater or equal to, less or equal to, is equal to, not equal to, then you have and or operators, right? So let's say I want to check a logic. So I showed you this part, right, that here in this code what we do, we check whether remainder is remainder of a number, we check whether the remainder after dividing the number by 2 is 0 or not. So I'm using this is equal to operator, right? So for all these three languages it's similar, but for some language you might have different syntax also. So such comparisons are needed in our code. So for that we have this operators, right? So let me provide a few values. My y is 3 and z, let's say it's 5. Okay, I run it. I have this 3 variables stored. Now I want to check, is x greater than y? So it's not x is not greater than y, right? So when I run this logic, logic has two values, either it could be 0 or it could be 1. So since x is not greater than y, I will get a value of 0. Okay, so logic is 0. I can check x less than y, let's say less than z, and if I run it, this logic is correct. You can add multiple conditions here, right? So x minus y, is it less than z? That is also correct. Now here one thing you can try is looking at and or operators. So if I want to see two conditions simultaneously, right? So I want to check whether x is greater or equal to z, whether y minus x is less or equal to z. I want to rely on two conditions, and if both of these conditions are true, then only I want to execute some part of my code. Okay, in that case you can use AND part. You can write single AND or double AND, it will work in both cases and provide you the logic. So here the logic is not true, that's why I'm getting the 0. Let's say if any of this condition is true, then can I get my logic. So here x is not greater than z, so this logic is 0, but here y minus x is less or equal to z, so this logic is true. So I have used OR operator, so in that case I am getting the value final logic as 1, right? So this is useful when you have multiple conditions in your code where you want to execute specific task if both conditions are satisfied, if only one conditions are satisfied. Okay, now you can further build into this same logic. So let's say Now I want to add further logic to this part. Okay, I have multiple logics in my system, so I want to understand either this two condition, either two of this condition is satisfied and necessary condition that x is less than 2, then only I should have my code should execute, right? So in that case you can further add the parenthesis and narrow down, like expand your logic. Okay, so these are the relational operators which are used when we will do further programming, specifically in the next lecture when we will use for loop and while loop. They are based on this relational operators, where this till the specific condition is met, your code will be executed. If that conditions are not met, your code will terminate, right? Now to add the complex number, you have this command complex ab. So if I type help complex, it gives me the idea of how to create a complex number, right? So I have to provide complex and two values, one is real part, one is the imaginary part. So complex AB gives A as a real part and B as a imaginary part. Now further related to this, you can see other commands also: imaginary, conjugated, angle, absolute value, real value. These are the part of your complex variable analysis, right? So if I want to look at, I am defining variable z is equal to complex of, let's say 10 comma 27, right? And if I run it, I have variable z created where the real part is 10, imaginary part is 27. Let's access the real part of z. So for that I can use command real. If I want to access the imaginary part, so I have command emj then z. If I want to find the mod of z, mod of the complex number, then you have absolute value, right? So if you run this, you can see first you get the real part, which is 10, imaginary is 27, and absolute z is nothing but under root square root of a square plus b square, right? So this is like sqrt. Sorry, 10 square plus square. So you get the same value. Okay, there is this conjugate command also. If you want to find the conjugate of your complex number, then you can use con z. So it will create the negative sign in your imaginary part. So this was with the what we have to do with when we have just numbers and we want to compare. Now let's move forward with the how to provide vectors in matrix in Matlab. So again, for its for us it's very here it's very simple. Let's say I have a vector A with an element 4, 5, 7, right? So I just have to write it in square bracket with spacing in between, and it will create a vector A. I can also create a vector B. So this here vector A, if I run it, it has created a row vector. You can see 1 row and 3 column, right? So vector A is created. I can access it through the workspace also, and I can see it's a row vector. Let's say I want to create a column vector. So in that case, same component, I have to just differentiate element by semicolon. So here semicolon will put the next number into the second next row. Okay, so same vector, same value vector, but now it's a column vector. So you can see 4, 5, 7, it's 3 cross 1 vector. If I want to add a matrix, so same way I can provide the first row, then my second row. Let's say this is my second row. If you want to further add your third row, you can do that. Okay, and this will create my C matrix also. Okay, so it's a 3 cross 3 matrix. Now in matrix, you can find now, so we have this vectors and matrix creation. Often we will need this since we work with multiple variables in our computation, so we will need this for linear algebraic calculations, vector calculations. So let's say I want to add two vectors together, or add the elements of vector, or multiply the elements of vector, right? So I can use same numerical operator symbols which we have seen here, right? The plus, minus, division. Let's say my variable A and B. Now I want to create a variable D, which is a combination of A plus B. So I want to add the element of A and B, but here my vector A is 1 cross 3 and vector B is 3 cross 1. Okay, so I cannot add them directly. I have to transpose the vector B. Okay, so you can use B dash. So what does B dash does is, it will create the transport of vector and then you can run. So B dash has transported this 3 cross 1 into the 1 cross 3 matrix, a vector, and then at the end you summation and you create the third vector, which is a summation of element of vector A and B, right? So this is a direction question. Now let's say instead of adding them, I want to do element operation. So I want to multiply 4 into 4, 5 into 5, 7 into 7. So I can create another matrix D1, which if you want to do an element operation, so same numerical operator you have to use.
Can't hear properly, sir.
Sorry?
Can't hear properly, sir.
Can't hear properly.
Yes.
Is it like voice is breaking, or I have to speak loudly?
Now, so some air is coming while you are talking.
Is it a slight buzzing sound? Because sometimes my
Buzzing sound.
okay, so that is because my laptop is heating, so it's a fan noise. Since I am recording also this lecture, and Matlab is also running. Okay, I will try to speak slightly louder, so maybe it's more clear to you. If
Okay.
it still doesn't work, then let me know. I will try to figure out what to do. Okay.
Okay.
Yeah. So if we want to do the element operation, so in that case you have to use same numerical operator, but instead of just using that symbol, you have to add dot into it. So this will do element operations. So I can do A dot B star, and it will do the element operation. So 4 into 4, 16, 5 into 5, 25, 7 square, which is 49. So it has done the element operation. Now for matrix itself, let's say you want to find the determinant. So you have determinant command that C, then you can put the value of your square matrix and it will find the determinant. Let's say you want to find the inverse of a matrix, then you can do that also. So you can see here it has computed the inverse of matrix C. Now further here, let's say I want to access specific element of a matrix. Now let me remove this part. So I have a vector A, vector B, and matrix C. So I want to access specific element. So let's say I want to access the only first row of matrix C. Then I can do this. So you can see when I'm typing C, it shows that first should be row and second will be the column part. So I'm using colon. So colon will include all the components in a row, and then 2, which will include, so it will give me the second column with all rows, right? So basically it will provide me the second column, which is this. If I want to access the first row, so for that I type the row number 1 and all the elements of a row, all the elements of that matrix. So it will provide me the first row, which is 2, 3, 4. If I want to access only the specific part, let's say I want to find the end part of end element, so I can use end, and it will give me the end part, which is n cross n value of your matrix, right? Similarly, you can use, I think, 1 gem 1 to find the first row. Okay. So this customization might be needed when you want to access specific value from a matrix. Okay. If I want to find the eigenvalues, so there are commands for that also. So if you will search help eigen, so it will give you the syntax for how to find the eigenvalue of a matrix. Okay, so here again I am using the C matrix. I want to find its eigenvalue, so I write eig and it gives me the 3 eigenvalue of our matrix. Okay, now let's say I want to find the eigen vectors also, then I can do this u comma v eig. So here it provides eigenvalue in the diagonal matrix and all and the associated eigenvectors as a matrix form, where each column corresponds to one eigenvector. Okay, so this is how you can compute eigen values of a matrix, right? Now again, when I was discussing about various languages, so here Matlab has this inbuilt functions which are which computes the eigenvalues, eigenvectors easily for a given matrix, right? But when we are working with a C++, if or any or Fortran, any basic language, then you might not have this all the functions available to compute it. So then you have to write your own code to compute the eigenvalue of a matrix, right? So this advantage you get with such object-oriented programming, Matlab and Python, that you have this inbuilt function which saves your time to find various properties or do various numerical analysis. Now these are the basics command that how to find the length of a matrix or size of a matrix. So here if I do the size of C, it will give me the rows and column of a matrix C, right? Now if I do length of a C, it will give me the maximum part, maximum of row or column. Now if my C is instead of 3 cross 3, let's say it's 4 cross 3 matrix. So in that case, when I do length, it will give me the maximum of row or column, which is 4, right? Now if you want to specifically access the how many columns matrix has, then you can use size command followed by dimension. So if you do size C1, it will give you the row. If you do size C2, it will provide you the column, right? So this is how you can access rows and columns of a matrix or any element of a matrix. Same thing you can do on a vector also. Again, this file will be available. I am going through the basic commands which will be useful further down the road, right? There are various ways to create matrix in the system also. So let's say you want to create a matrix which has all the 0 elements. So I can use command zeros, right? So which creates an array of all 0. So if I type 0, 3, it will give me a 3 cross 3 matrix of all the component as 0. If I do z is equal to zeros 3, 4, So I am providing two size. So first will be row and second will be column. So it will create a 3 cross 4 matrix of all the elements as a 0. If I want to create an identity matrix, so I can use I command, and it will create an identity matrix with all the diagonal elements as a 1. Okay, then yeah, inverse of matrix determinant we have seen, matrix operation I have discussed. One more thing, that when you want to create a vector between two data sets, so for that you can use line space command or this command. We will come to this. First let's look at the line space. Here if I search for help, line space, so it provides linspace linearly spaced vectors. So linspace x1 x2 generates a row of vector with 100 linearly equally spaced point between x1 and x2, right? So if I do linspace 0, 1, it will give me 100 points between 0 and 1. All of them are spaced equally, right? So you can see I have created a vector with 100 elements. Now let's say you want to control it. You want to control how much spacing is kept between all the elements. Let's say between 0 and 1 I only want 5 data points. Then if I provide the third part 5, it will create vector with 5 elements between 0 and 1 which are equally spaced, right? So this is how you can create equally spaced vector between two data points. This might again, the use of these things will come further down the road when we will do coding and stuff, but just for the sake of now, like, you understand the idea behind these commands. Let's say I want to create and 1. So if I just type x colon 1, it will create elements between 0 and 1 with a default spacing of 1. Okay, so here I have typed 0 colon 1, so it has created a vector x with a default spacing of 0 and 1. If I do x 0 colon 0.5 colon 1, so it will create a vector between 0 and 1 with a spacing of 0.5. So I can see I have two elements. Same thing I can do 0.25 and I get this. So this is how you can create, these are two different ways to create equally spaced vectors between two data points. And for plotting, you have this command plot yx. So if I don't provide both values, let's say I just do plot x, so what it will do, it will generate a plot for all the elements with its corresponding indices. So here I have 5 elements. So element 1 is 0, element 2 is 0.25, 3 is 0.5, 4 is 0.7 and 5 is 1. Now you can interact with this entire plot also. So you can see, I can see the value of data points in between. In the next lecture we will further see how we can do customization to this plot and interpolate data from this, right? If I provide the value of plot, let's say, let me create another matrix, y is equal to 2, 5, 7, 8, 9 and 11. Yeah, okay. And I do plot yx. So I will create, so this is y versus x plot. You can also use, if you want to visualize any function, how it will look like, then you have this ez plot command. For the ez plot command, if I type this, I want to see how the x cube will look like between -3 and 3, and if you do this, you will get this plot, right? Let's say if I want to look at the plot of x square between -3 and 3, so it will be parabolic. You can see this is how it will look like. Okay, so you have also tool to analyze some sort of equation how it graph will look like through EZ plot. So if I search help EZ plot, yeah, you can see the description of EZ plot, how what exactly it does. Further you can see the documentation part with various examples of how this thing works. Okay, so these were the some of the basic commands. Even in plotting also you have further contour plots, histograms. Even in EZ also you can see you have contour, EZ, field contour, mesh plot, 3D plot. We will come to all this further down the line, the road, right? So you don't have to worry about it. If you will do the basic introductory course which I have mentioned, you will get familiar with this various commands, right? So it will be slightly easier to get equipped with the next part. Now having this, let's we have 20 minutes. I think that is sufficient to do this quiz part. So I have compiled some of the questions which are kind of similar to what you have in your assignment part. So for this part I will need response from you guys. We will see various questions and try to answer it. Okay, I will also solve that with you. So question 1, which command is used to stop the execution of Matlab command or
Control
Matlab
C.
script? Control C, right, correct, right? So then which command is used to clear all the data and variables stored in the memory?
Oh yeah, CLC.
No, CLC is actually to clear the command window. If you
Clear.
want to create, so you can use clear, and if you want to specifically remove any one variable, then you can write clear and that variable name. Okay.
Okay,
Now,
thank you.
yeah, which command is used to add a comment in a MATLAB file? We started with this only.
Option A.
Yes. So yeah, percentage symbol you can use to add a comment in a MATLAB. Right. Now the next question is find the eigenvalue of a given matrix. Now I don't want you guys to solve this, so we will use MATLAB to solve this. Okay. So find the number of eigenvalues of a given matrix. We have a matrix 1, 8 and 2, 1 as an element. So let's go into the MATLAB. 1, 8, 2, 1. Okay. Yeah. Then eigenvalue of A. So I'm getting 2 eigenvalues. So my answer will be A has 2 eigenvalues. Right? Now find the eigenvalues of given matrix. So it's a 3 cross 3 matrix. Do any of you can access MATLAB online right now, or you want to try it in that? If you can do and find the answer. Yes, no, or should I do it? If you can access it and find the answer. Anybody is doing, or should I do it? Okay, let me try. So now I have 3 cross 3 matrix with element 4, 1, 3, 1, 3, 1, 2, 0, 5. Okay. Find the eigenvalue of A. So I have 3 eigenvalues, 1.8, 7.1 and 3. So here it's matching only one value, 3, right? So this is my answer. Now next question. So what is the default extension of Matlab script file?
Something.
What? Sorry, can you repeat it? Can you repeat it? Sorry.
Option C.
Option C. Yeah, .m. And .mlx is also one format, which is a live script where you can see the results side by side. Okay. This is the Excel extension, and .txt is text file. Now, what is the special character used in the Matlab to provide the value of pi? This also I showed. How I can put the value of pi in the Matlab? We had used one character, right? Can you recall it? It's pi, pi, just pi.
PI.
Yeah, right. So if I type pi, it will give me the value of pi, which is 3.1456. Now, while doing MATLAB programming, if I'm encountering this error which says NaN value, what does it mean? Have you tried various numerical operations and encounter any such number? No, I guess you might not have. So let's say when I'm doing this, when I'm doing any numerical operation, yeah, right. So this numerical operation is working, it has a finite value and I'm getting that answer. But let's say when we encounter something like 0 by 0 in our system or infinity by infinity in our system. So 0 by 0 is not possible, right? We cannot compute 0 by 0, infinite by infinity is not possible. So it will give you the value as a NaN. NaN means not a number, so it doesn't identify it. You can do 1 by 0, which will give you the infinity. You can do 1 by infinity, which will give you the value of 0, right? But when we encounter this, you will get an error of NaN. Okay, so if you will look help NaN, so NaN is not a number. It comes when the operation like 0 by 0, infinity by infinity, such things occur. So NaN stands for not a number, generally encountered when we are doing such operations where both the components are 0 0 or infinity infinity, right? Now next question, you have two vectors A and B with size 3 cross 1 and 5 cross 1, so both are the column vectors. Which of the following command is useful to combine this vector, and can you guess it? I'm not sure whether you will have come across this on MATLAB on RAM, but can you think about it? If I want to combine two vectors, which of the following command will be useful?
A.
C. You are saying C. Okay.
A option.
Option A. Yeah, we have two answers, right? So let's say I don't know. Okay. I'm also kind of you and starting. So what I will do, I will create a matrix and try it. Oh. Yeah, let me use this. So I have A matrix with 3 elements. It's a column matrix, right? Yeah. B has 5 elements. So again 1, comma 2, comma 3, comma 4 and 5. Okay. So one is first, let's try A plus B. Does it work? No, it shows an error because A is a 3 cross 1, 1 cross 3 cross 1 matrix and B is 5 cross 1 matrix or a vector. So it cannot do the summation since they are of different size. what other option we had? Someone said this option A, right? So C is equal to A, comma B. So does it does? No, I have to comment this. Dimension of array being contracted are not consistent. Well, just a minute. Oh, it's a row vector. Yeah, sorry, my mistake. Huh. I have considered as a column. So if I have a row vector and if I want to combine them, I can use this. So C becomes this 1 cross 8 matrix where the elements are combination of A and B. Now let's say we had the other case where I want to combine two columns. In that case, I can use this part. A dash will be the column vector, B dash also becomes column vector. So now I'm combining two column vector, right? So I'm getting 8 cross 1 as a column vector. So if you want to combine two row vectors, you use option A. If you want to combine two column vectors, you use option D. Okay. Now, which of the following command is useful to find the transpose of a matrix? This is easy.
Option B.
Yeah, option B. We just right now I used it, right? There is this option also, rotate 90. This is actually a command. So if you will use it, rot 90, it will rotate the value to the 90 parts, right? So 1 2 3. This is different from the A dash, like it's different from the A transport. A transport gives you, it converts row into the column, right? But 90° it reverses the value, right? You might encounter this command somewhere, you might need it, but there is this command which exists. Now I have given this matrix X and I want to find the mean value of vector. So what we will do is let's add this vector X equal to 1 1 2 3 4 2 3 1. 3 1 2 3. Yeah. 4 2 3 1 3. And I want to find the mean. So for mean you have command mean X and you get the mean value. Similarly, there are other commands. I have written, yeah, L function, help EL func. So these are the statistic analysis on the vector, right? So for that you have commands, default commands as real image. No, it's not here. You can also find the median, standard deviation, mod value of a vector by using this command, right? So let's say I want to find the mod value here. So I can use mod X. So it will give me the most repeating value, which is 3 here, right? So this is how you can perform also various statistical analysis through this. Now, which of the following command is used to close the Matlab completely? Do you know? So there are these two options. either you can type exit or quit. So if I type exit on my command window, it will forcefully close the entire Matlab. Okay. Next, what will be the logical answer of this? So is this logic correct? If I do 3 right division by 5, is it equivalent to 5 left division by 3? Yes or no? Can you think about it? No? Is it yes or no?
No.
No. No, actually it's yes, right? So see, I already told you, right? So if I do 5 by 3, it will divide 5 by 5 with respect to 3. If I do 5 left division 3, it will divide 3 by 5. Okay, so I get 2 values. Now here what does it say? 3 division by 5, 3 right division 5, is it equivalent to 5 right left division 3? So see, this both are correct, right? So first is dividing 5 by 3, second is also dividing 5 by 3, but the syntax is different. So if I put the both logic together, 5 by 3 is equal to 3 by 5, my answer will be 1, right? So its logic is correct. For the variable, which of the following statement is incorrect? First option is it should start with a letter. Second is it can only consist letter, digits and one special character, which is underscore. Variable names are not case sensitive, and last option is variable name can be as long as we want. Which is incorrect? It's easy, we discussed already, right? Yeah, it's C. Variable names are case sensitive. Okay, so this is incorrect statement that they are not case sensitive. We already saw that if I write capital A and small a, it will consider 2 different variables. Now regarding the size of variable, you can put a much longer name. I think it identifies first 31 character of a variable name, right? So you can use a longer name for your variable, still Matlab will consider it. Which of the following is not a format option in Matlab? This I have not discussed. So format option here is format. So there are various format options. Basically it means that how you want to represent your data set. Okay. Here you have format short, format long. So short means fixed point format with 4-digit accuracy. If I do format long, so long fixed point format with 15-digit after the decimal. So if I do long format, it's more accurate than the short, right? Similarly, if you have used any other language, you use float and double, right? So for float, after decimal you go to probably 6 or 8 points, 8 digits, right? While double you go till 16 digits. Okay, so this way if you want to change the accuracy of your result, so I can check what format I have. By default we have a short format. You use this command fmt equal to format to see what format you have. So by default we have short format, line spacing is loose. Now let me change format to long. Before that, let's say I type the value of pi. I get after decimal 0.4 values, right? Now I'm changing my format to long, and if I now type the pi value, you can see my decimal values, my digits after the decimal increases. So this can be useful to enhance the accuracy of your numerical methods, specifically when you are working with much finer data sets which are in point values, in fractional values, right? So in such cases, using long format is helpful to get better accuracies. Okay, there is another format rat or something, rational. Rational. So this gives you the rational value. So it won't convert it to the decimal part, right? So what other options we have? We know format long, format short, hex and medium. So I can see format hex here, which uses hexadecimal format. Okay, so the incorrect answer is medium. There is no format medium. What will be the output of complex 2, 3? It will create a complex number with
Ask EI.
2 plus 3i, right? 2 as a real part, 3 as an imaginary part. Now there are only 4 questions left. So we have to create a mixture with 2 components x and y, whose composition should be 30% x, 70% y. 2 solutions are available, A and B. Composition of A is given, composition of B is also given. Now how much A and B we should use to generate a 100 kilogram mixture? So this is a basic example of mass balance that I want to do. Now I don't want to use pen and paper to compute this. We will use Matlab to compute this answer. So for that, first here let's understand our problem. We have a mixture of A and B. So one will be the overall mass balance. We have to create a solution with amount of 100 kg, right? So A plus B will become 100. This is our one equation. Then I can do the component balance of x and y, right? So A contains 25% x, B contains 35% x. So 0.25 of A into A plus 0.35. 0.35 into B is equal to, I want 30% x, so 30 into 100, that 30% of 100 is 30, right? Then mass balance on B will be so 0.25, so this is 0.75 of B, 0.65. So this, we have to solve these 3 equations. Basically 2 equations we have to solve, right? So these are linear equations, and generally when we have linear equation system of equations, we use a vector algebra, right? We use this I forgot. Just a minute. Let's say I want to solve it, so I will do lean solve. Help. So lean solve solves the linear system with Ax equal to B, right? So this is our system of equation. If I convert this system of equation into matrix algebra, right, my coefficient matrix will be 1, 0.25, 0.25, 0.75, 0.65. My X will be 2 cross 1 matrix which contains A and B, and this B value will be the right hand side part, right? So this is kind of similar to this equation. It will use LU factorization to compute the answer. So let me create 2 matrix U, which contains the component 1, 1, 0.25, 0.35, 0.75, 0.65. Then we have V matrix as 100, 30 and 70, right? If I do lean solve u comma v, it will give me my answer 50-50. Right? So what it has done, it has used this data. So we have converted our system of equations, mass balance equations, into matrix algebra, and lean solve uses LU factorization to find the resultant value of x, right? So this again goes to your numerical method aspect, and we are using that to solve this system of linear equation. So 50 kg of A and 50 kg of B is needed to create an entire mixture. Is this part clear to you guys? You are understanding what I am doing here? Yes?
Please open the Matlab part.
Yeah?
In the answer, it shows 50-50, but it's not specify which is A and which is B. If the answer we get 30 or 30-70.
Yeah, so that is that will be the coefficient that will multiply, right? So here it's 1 1. So see, this is how it is, right? Equation is A into x is equal to b. So A is your coefficient matrix, x is your variable matrix, and b is the right hand side part. So here 1 1, so 1 into A plus 1 into b will give you 100, right? So maybe I can write it somewhere. So you have this, so this is how our system of equation will look like. So this is A, this one is B, right? 1 cross 1, you will have 100. Then this one is 0.25, 0.75, 0.75. Okay. Here you have 0.35, 0.65, 30 and 70. Correct? Now you are understanding. This is how. So all three of our equations will look like this in the matrix algebra. So if I simplify this, if I do the matrix operation, 1 into A plus 1 into B is equal to 100. 0.25 into A. So when I solve this, so I provide this matrix U and V. So first answer will correspond to A, second will correspond to B. Okay. Is it clear now?
Yeah, got it.
Okay. Now, I have to finish faster. Yeah. So solve this equation. So for that, so this is just to get used to the parentness part. Okay. You just try it out. So basically you have to specifically follow this parentness. So let's say I have 3 multiplied by, first I have root 5 minus 1, so which is sqrt 5 minus 1, which is divided by square of root 5 plus 1. Okay, so sqrt 5 plus 1 square, this entire thing minus 1. Okay, let me change the format. So my answer is 0.645 minus 0.6459, right? This is just to get used to the bracketing and parenthesis part, because sometimes you misplace the bracket and your answer will be different and you might be wondering what is happening. But when you have such complex equation, be mindful about where what is divided by what and where you want to do multiplication. We have an equation of straight line where slope and intercepts are given, and we have to find corresponding y coordinates. So we have x coordinate as 0, 1.5. Let's do this. Three, 4, 5, 7, 9, 10. 7, 9, 10. M is given as 0.5 and C is given as -2. Okay. Now, so I have to use line equation y is equal to mx plus c. So I know m. I want to multiply m with each element of x. So I can do m dot x plus c. Let's see if this works, or I'm getting an error because m dot x is a vector while c is a single integer value, right? Single point value. So here also I have to do elementary operation, so that I have to put dot plus in front of plus, and then you will do it. What happened? Dot indexing is not supported for the variable of this type. Just a minute. Shoot. Y is equal to mx plus c. It's directly doing it. Oh, sorry, it has done it directly. Yeah. So since it's only one component, so you can directly multiply it, or you can use this element operation. Then also it will work. Yeah. So this is a single element. I don't have to specify dot plus c. It will directly add all the element 2 plus c. Okay. So this is the value. So I have -2, 1.25, 0.5 to this range. Is this our answer? Yeah, it is. We have been also asked to plot this graph. So let's plot this. Plot yx. And you, since it's a MLX script, you will get plot here. This is how our plot looks like. Okay. So it should be xy. Yeah, anyway, it's fine. Now, next and last question. So we know the sum of geometric series is given as this equation, right? Where r is not equal to 1 and a is equal to 1 is given here. So if we take r is equal to 0.5, then we have been asked to find the sum of geometric series which has 10 points, n is equal to 10, by equation and by summation of series value. Okay, so here what I have, let me note down all the data. I have r value as 0.5, a value as 1, n as 10, right? So these are the geometric series data. A is equal to 1, r is equal to 0.5, n is equal to 10. Now I want to find the summation of this geometric series. One is by equation and one is by summation value. So by equation I have to use this a into 1 minus r is to n divided by 1 minus r. So that will be a into 1 minus r raised to n divided by 1 minus r. So this is the value 1.998. So if we know the equation, we can use directly. But let's say I don't know the equation and I have to find the values. Okay. So for that, what I have to do, I have to create 10 data points for this geometric series. So for n is equal to 0 to 10, I have to create this value. So for that, what I will do, I will create a vector which starts from 0, goes to 10. Okay. Not 10, 9. Yeah. So I want 10 data points, right? So 0 to 9. So it creates a vector x with 10 data points, 0, 1, 2, 3. So n is equal to 0 to 9 it's going. Okay. Now corresponding to that, I will find each element. So r raised to 0, r raised to 1, r raised to 2, r raised to 3 up to r raised to n minus 1, which is 9. Okay, in our case. So I have to find that. So I can create y is equal to r element x. Okay, so I want to take the r value and so if you do this, it has also created the corresponding y vector for geometric series. Now I have all the elements in the geometric series, so I can use sum y, right? So this, by equation and by summation, I am getting both the same value, 1.998 or 1.998, right? So in cases where you already know the equation for your any series summation or any final value, then you can directly use that. But if you don't know that, if you have a very different series, then you have to compute its element and then find the summation, right? So this was just to demonstrate that part. So this is it for today's class. We will meet for the next class in the next week, same timing, Tuesday 6 to 8 p.m. For the next class, I will focus on the basics of looping, conditioning, how to create various functions, and plotting part. And then from third week onwards, we will focus more towards the chemical engineering problems. Okay, so that's it. If you have any doubts, we can discuss. I am stopping the recording. This will be available to you on the Swayam portal itself.